Okay, let's do a couple more general functions, f of x, sort of general functions, not economic applications. Let's start out with, let's see, f of x equals negative 2x cubed plus 12x squared minus 30. Let's start out with that. So the first thing we're going to do is we're going to find the first derivative, which is negative 6x squared plus 24x. Now again, notice that this slope changes as a function of x. It can be positive or negative. Now that tells us a lot, again, because we're not dealing with a function that's smooth like this. We're dealing with a function that probably looks something like this. Okay, so it's where the slope can change depending on the value of x. So that tells us a lot. Okay, now we're going to go to the second derivative, f double prime of x. F double prime of x is negative 12x plus 24. Now that tells us a lot too, because that tells us we're going to have an inflection point. Why? Because the concavity changes as a function of x. It's going to be positive for some x and negative for other x. So right now what we need to do is go ahead and set up our graph. And we're going to first find the inflection point. We do that by setting the second derivative equal to 0. So that's negative 12x plus 24 equals 0. So the x-coordinate of our inflection point is going to be 2. To find the y-coordinate, we need to plug that back into the original function and find f of 2. Okay, so f of 2, breaking out our trusty calculator, f of 2 is going to be, let's see, negative 2 times 2 cubed plus 12 times 2 squared minus 30. Okay, so f of 2 equals 2. So out here at x equals 2 and y equals 2, we've got our inflection point. Okay, now we need to find, since we know we have a function like this, we need to find the max and min. Okay, and I don't know, you know, this function could either look like this or it could look like this, right? I mean, or something like that, right? I mean, we don't know which way this function is flipped until we find where those maxes and mins are. And we find the maxes and mins, of course, by setting the first derivative equal to 0, because that's where the slope is going to be 0. Okay, so negative 6x squared plus 24x equals 0. We'll factor out an x, and we get x times negative 6x plus 24 equals to 0. So x will either equal 0 and x will equal, let's see, that would be 4. So at x equals 0 and x equals 4 is where our maxes and mins are going to be. Okay, so now we need to go ahead and find the y-coordinates of those maxes and mins. When we set x equal to 0 and we find f of 0, we're going to get negative 30. Okay, that's easy enough. So this is x f of 0 equals negative 30. Okay, so at x equals 0, we come down here to negative 30, and we get a max or a min. Now we need to find f of 4. F of 4 equals, I'm going to plug this into the trusty calculator, because I can't do that in my head, as negative 2 times 4 cubed plus 12 times 4 squared minus 30 equals 34. So up here, you can go ahead and extend this a little bit. Okay, so up here, somewhere, 34, and x equal to 4, we're going to have our other critical point. Now we can see what this function looks like. This function looks like, now we can sketch it in. This function will look like this. Okay? And so that's easy enough. So we just sketched in that function. Let's do another one. Let's see. Let's do f of x equals, pull this down some, f of x equals, let's see, 3x cubed minus 36x squared plus 135x minus 17. Okay, so the first thing we're going to do is we're going to find the first derivative, which equals 9x squared minus 72x plus 135. Then we're going to find the second derivative, which is f double prime of x, which equals 18x minus 72. That's an 8. 18x minus 72. Okay, again, this concavity changes as a function of x, meaning that we are going to have an inflection point. Let's go ahead and set up our graph. Okay, so let's find our inflection point by setting the second derivative equal to 0. That's 18x minus 72 equals 0. 18x equals 72, and therefore x equals 72 divided by 18 equals 4. So at x equals 4 is our inflection point. Okay, so what is f of 4? F of 4 is 3 times 4 cubed minus 36 times 4 squared plus 135 times 4 minus 17. That is 139. Okay. Let me refrain from putting that in here since we don't know where the other one is, and so we're going to try and fit this in to this graph. But this is the y coordinate for our inflection point. Now let's go ahead and find the max and min, because we know we should have one, because this slope is going to change as a function of x. So we know we're going to have a max and min. We know we're going to have one of those humpy functions. We just don't know what it looks like. Setting 9x squared minus 72x plus 135 equal to 0, we can break out our quadratic formula for that, right? So that gives us x equal to negative b, which would be 72, plus or minus the square root of 72 squared minus 4 times 9 times 135, all divided by 18, 2 times 9. So let us calculate x then. So that is 72 plus the square root of 72 squared minus 4 times 9 times 135 equals 90 divided by 18 equals 5. So x equals 5 and x equals 72 minus the square root of 72 squared minus 4 times 9 times 135 equals 54 divided by 18 equals 3. So x equals 3. Now what is f of 5? F of 5 is 3 times 5 cubed minus 36 times 5 squared plus 135 times 5 minus 17. So that is 133. Okay, what is f of 3? F of 3 is 3 times 3 cubed minus 36 times 3 squared plus 135 times 3 minus 17. And that equals 145. Okay, so now we've got all of our critical points, and they are between, so all of our graph is going to be between 133 and 145. You can see why I held off on this, just because I wanted to find these other 2 points in position to one another. So we're just going to call this 139. We're going to call this 145, and we're going to call this 133. Again, we're not worried about scale. We're sketching this in. We want it to be graphically correct, but doesn't, the scale on the axes can, pretty much be whatever it wants to be. So at x equals 4, that's our inflection point. At x equals 5, out here, we've got a critical point, and at x equals 3, back here, we've got another critical point. Okay, so what do you think this graph looks like? Well, that's our inflection point. So this graph must look like this, right? Now, how can we check that? Well, we can check that because f of 0 is negative 17. So this graph actually comes down like this and crosses at negative 17. Okay, so this has to look like that. Okay, easy enough.